So thank you all of you for coming to my talk, Testing with SPOC, the logical choice. And what is a SPOC? SPOC, it's a Groovy-based testing framework for Groovy and for Java applications that makes us write test fun again, because we can write highly expressive tests using all the power that Groovy provides us, and also the nice DSL that SPOC has. SPOC is totally compatible with JUnit. So you can use your standard tools, such as your IDEs, IntelliJ, Eclipse, your build tools, such as Maven and Gradle, or your CI servers, for example, Jenkins. So during this talk, what I'm going to show you is nice features about the SPOC. So maybe for your next project, you are going to try to use SPOC. But first, let me introduce myself very quickly. I'm Ivan Lopez at Ilomar on Twitter. I work at Kaleidos. We are a technological company based in Madrid, in Spain. I work as a Groovy developer. I've been using Groovy for the past 6 years. I'm the organizer, the coordinator of the Madrid Groovy user group, and the organizer of Gridge. Gridge is a Groovy conference in Madrid. Our next edition will be the 5th, and will be next April. You have all the information on the website, and I'm also a regular speaker in some talks. So I could spend something like 25 minutes talking about why you should test your applications and about explaining a lot of topics about unit testing, the different kinds, all that stuff. But I assume that you all test your applications, right? Do you test your applications? Okay, perfect. So instead of that, what I'm going to show you is show a SPOC in action. So this is basically my last slide. And let's go here. Can you see? Can you see the font size? Yeah. Okay. Perfect. So this is a Gradle project. So this is, and this doesn't exist yet. So this is the thing that you need to start, or you need to do for using a SPOC. I'm applying the Groovy plugin. I'm defining a repository, Maven Central or JCenter, and I only need to add Groovy and SPOC, and that's all. So now with that, sorry, we can write our first test. So the first thing you need to do is to create a class and just extend from a specification. This is a SPOC lang specification. And as I said, it's compatible with JUnit. It has this runner. It's called SPOCnik from SPOC and JUnit. And that's all. You don't need to worry about all these things. Just extend from this class. And what SPOC allows us is write the test in this BDD form given when then. So for example, if you write JUnit test, you probably do something like this. You can put the given when then blocks in comment to split your test. With a SPOC, you don't need to do that. You are forced to write the test just like this. And another thing is that you can write your test in plain English. So should reverse a string given something, and a string. When, this is what I want to test, when reversing it, then it's reversed. This is what I expect to happen. And you can see here, I don't need to write assert. It's automatic. Everything here is an assert. So I can run it, and it will pass. So another difference with JUnit and this given when then is that, for example, as I said, SPOC forces you to write these things right. So you cannot do something like this. True. If I try to run the test now, it won't even compile. You can see here. Because it's not allowed to use that word there. So you are forced to write the test well. All right. And another thing that, or another way to another, instead of writing the test just like this, you can use this form, which is expect. It's basically the same, but sometimes it makes sense to write something like this. So what I'm expecting is that when I reverse this word, it's something like this. Okay, so let's move to the next example. So it's important that when a test fail, have a nice report or a nice output of why the test failed. So let me first comment this with this at ignore annotation. Your test is not going to be executed, and SPOC has another ignore rest, which basically means I'm going to only execute it. I'm going to only execute the tests that have this annotation. I'm going to ignore the rest of them. I'm not going to do that. So as you can see, this is not going to pass because 6 is not 20. So let's run and see what happened. Okay, it fails. And you have this error. 2 plus 3 is 6, and 5 plus 4 is 20, which they are not the same. This is called power assert. This power assert thing was developed at the very beginning in SPOC, and then they were moved to the Groovy core. So inside of your Groovy application, you can write assert something, and if it fails, you will have a report something like this. This is a pretty simple example, but I have here another one, which is it's different. So here I have maps and list with some keys and values, and what I expect is that the name of the first child is Adriana. So let's run this test. And you can see here this nice report. So data contains all the information. Childs gets only the childs on that data. So this is key. This is a map. The name is Judith and Adriana, only the name of that map. And the first one is Judith, which is not Adriana. And you can also see here that they are 40% similar. I think they're more because they are my daughters and they are more similar. But the nice thing about that is that you can see in every step what happened. So now it's very, very simple to see why the test has failed and how to fix it. Okay. Next one. So as I said, you can use a SPOC to test your Java applications. So what I've done here is create this Java code. You can see it's Java because it has semicolons. It's very verbose. And here I'm writing this Fibonacci sequence: 1, 1, 2, 3, 5, 8, and 13. So I'm going to test this Java code. So here I get the numbers, and I'm going to test what happened when I add a new number. This is the same as numbers.add21, because in Groovy, for collections, this left shift operator is overloaded. So you can do just like this. And I can check that now the list contains this 21 number. Okay? And we can do the same with maps. So here I have this map with these persons. Person is just a pogo with name and last name. Sorry, a pollo with name and last name and setters and getters. And I'm just returning this array list with 4 persons. And here you can see nice things about using SPOC and using Groovy for testing. So I'm going to put it here. So you can check that the size is 4 because I have 4 persons. I can get the names in this order: Sheldon, Leonard, Russ, and Howard. I can also get the name sorted, which now it's because I'm not defining which sort I want to use. It's alphabetically by default. So Howard, Leonard, Russ, and Sheldon. Here with Colette, I'm getting the last name. And with Colette, I'm creating a new list with the size of every last name. So it will be 6, 10, 12, and 8. And I can also get the name of the person with which his name is the minimum length. So another thing, probably, this is, if you are not very used to Groovy, how many of you are Groovy developers? Okay, so nothing, no one, great. So you are not used to this syntax because remember, this is an array list of pollos, so they are objects, but you can do just like this. So you can do here print persons.name, and as you can see, IntelliJ know that there are persons there, so you can have auto-completion. You can also do persons.collect, and here I can say the name, it's the same. I can also use this spread operator, which basically means I want to execute the next one for every element of the list, which is the same. And I could also use, if you are used to lambda, to Java 8 lambdas, this is a Groovy closure, but it's basically the same. So I can do persons dot stream dot, for example, for each and print line ID. I'm not really sure about it. No, let's comment this. So I can run it now. And you can see I have always the same result. So you can manipulate in a very easy way lists and maps using Groovy. And here I have this map with these keys, name Ivan, last name Lopez, age 36. I'm returning this map here. So I can also test what happened when I remove the key name. The key size will be 2, because now I will only have last name and age. So I can also check that the key set doesn't contain the name. And here, these are the same 3. So the first one, it's the Groovy way to access a key on a map. It's just map.key. This is more Java, get, or this is the other way to use. So the 3 of them are valid. The first one, this one here, it's more Groovy idiomatic, but you can use anything. If you are Java developers, you are basically Groovy developers. The only thing you need to do is rename your Java files to .groovy files, and that's all. You can start using Groovy with that, and then you will start learning tricks and do something like these things. Okay. So let me close this. Exceptions. Sometimes you want to check that the code that you are testing throws an exception. And probably with JUnit, something like that, you can, what you do is write a try and catch block and put a comment on the catch because it's empty, and I'm pretty sure that it will pass. With SPOC, we have this thrown. So what I expect here is that when I execute this long value of foo, this is not a valid number. So I expect that it will throw a number format exception. I can run it, and it will pass. And another nice thing that you can do with this is that you can save this here. So I can say, okay, this is an exception. So I can assert whatever I want in that exception. For example, the message. And I can say, let me check my notes. For input string foo. No. Oh, semicolon. Colon. Okay, so as you can see, you can check a lot of things in your exception. And in the same way, let me cheat a little bit. I'm going to copy here. Should not throw an exception. You can, if you can also do the same thing with, instead of thrown, not thrown number format exception. Okay, this is the same. Let's run it. The test should pass. Okay, and another thing is that here you are pretty sure that this exception is that what you expect. So for example, if I put here null pointer exception and I run the test, it's going to fail because I was expecting null pointer exception, but instead I've got number format exception. So with these thrown and not thrown keywords or methods, you are pretty sure that you are going to test what you expect to test. Okay. So sometimes you have the same piece of code and you want to test that code with different data. So with a SPOC, you can write just like this. This is a very simple example. I want to check that these numbers are even. But I can write this. In this word block, I can define variables, so number, and I define a list. So this 10 is going to be executed for all of these, one every time. So -10, 0, 2, 42, and 1000. And you can do more than one variable. So for example, you can put more than one. The minimum between x and y, it will be this result. And you can put this 3, 1 here. The problem with this is that you need to read this in column mode. So the minimum between 1 and 2, it's 1. And -2 and -1 and -2, it's -2. So it's not that readable. With one variable, it's pretty nice, but with more, it's not that simple. So instead of this, we can write this word block in a tabular mode. So it's the same. But now you are reading in row mode. So x, y, and result, the minimum between 1 and 2, it's 1. Let's run, for example, this test. Okay, the test passed. And you can see here that I only have one execution. But what happens if one of these fails? So for example, I can do this, run it again. Now the test is red, and I can see why it fails. And this is a very simple example, so you can say, okay, 0 and 1, this is the wrong data. But in a more complex test, this is not very useful. So what we can do is use this enroll annotation. We can we can put this annotation on this method. The code, it's the same. And now, what the SPOC is going to do, it's this. I have 3 different executions for every data. You can see here 3, 0, 1, and 2. And if this failed, now I can see that this is what fails. But we can do it better. So the next step is do something like this. Here. Sorry, I changed the wrong one. So you can see here, this is what failed. And as I said, we can do it better because we can use this thing inside of our methods of our method name. So now for every execution, this data here, it's going to be replaced here on the name of the test. So let's run it. And as you can see, should check that the minimum of 0 and 1 is 0. So it's a very, very nice way to have your test report with right names and see what happened if in case they fail. And the last thing I want to show you about this is that here in this example, I'm using a list, but you can use anything that it's iterable. So in this example, what I'm doing here, let's start by the end. I have these files, users. So imagine this is a CSV file with name and last name. And what I'm doing here, it's basically parsing this CSV file, reading the lines and returning a list. And this is a very bad way to parse a CSV file. So please don't do that on production. It's for a test, it's for a demo, it's fine. But for production, you don't want to do this way. So what I'm doing basically is returning a list with all the data parsed. And I'm saving in these variables the name, the last name. So this is my word, so this is my variables. And now what I'm doing here, this is a Groovy map with key and value. And this as person, it's a Groovy trick. It's called coercion. So what Groovy it's doing, it's basically coercing this map to this person class, because it has this name and last name attributes here. So it's going to create a new instance of the person with this trick, with this as something. So what I expect is that now person is an instance of my person class, and I can check that the name and the last name are the same that I read here. So let's run this test. Okay, and in case you don't believe me, I can do something like this. I'm going to add a new value, and I'm going to do here the same trick with enroll. So I can say the name equals the name, last name equals the last name. So if I run this again, you can see that you have all the values in every iteration. Okay? Let's move to the next one. Lifecycle. SPOC has this lifecycle, and basically here I have these two tests that don't anything, just print test and test2, and we have these methods here. So I can define this for any of these methods, and setup spec is going to be executed only one time at the very beginning of the whole class execution. Then setup will be executed before every test. Cleanup will be executed after each test, and cleanup spec will be executed at the very end. So you can use these methods, for example, to create to open a database connection, to clean up some resources, something like that. So let's run this. Okay, and you can see here setup spec executed at the very beginning, then setup, then the first test here, then a cleanup for this test, then setup again for the second test, again cleanup, and at the very end cleanup spec. You can define any of those. It's not mandatory to define the 4 of them. You can write whatever you want. And sometimes in some tests, you want to share a variable or some object in all the tests. So here I'm just printing the person, and I want to share this. This is an example, but imagine here that instead of creating this person object, you are creating an expensive resource. So you don't want to create that resource every time for every test, because this creation could be very expensive. So if we use the things that we saw in the previous example, this life cycle, we can write this. So what happened if I run this is that we have different person for every of the tests. So we don't want to do that. We want to share the same person. Okay. So we can write this just like this. We can define def setup person. And this is basically the same, but with more code. So it's not useful. We still have different persons. So what you may think is, okay, instead of use setup, why you don't use setup spec? Okay, because it's going to be executed only one time for the whole test. So let's try it. No, sorry, wrong. I need to execute the complete test. And what happened is that it doesn't compile. And this is the error. Only a char or an static fields may be accessed from here. So this is actually the solution we are looking for. So what we can do is something like this. We can annotate this at share. So now, if I run the test again, we can see that we have the same instance. And the nice thing about this annotation is that when you read this test in the future, or some of your colleagues, it's pretty simple that you said, okay, it's there, so I think that this instance is going to be used in every test, and it will be always the same. So it's also a way to document your tests. Okay, mocking. So when you test your code, sometimes, most of the times, you have, for example, you are unit testing this code, and here you have a collaborator. And when you unit test this code, you don't want to deal with it, because you are going to unit test this code in another place. So one thing that, or one technique that you can use is just mocking this collaborator. And mocking means in SPOC that I only want to be sure that this collaborator is executed. I don't care about what happened. So here I have this. What I'm going to do is I want to create a new user. Okay. So let's see this user service. It's really simple. Imagine that here you are using, for example, a Spring. So you have here, you are injecting this notification service. And this is the method you want to test. So it's a demo. It's pretty simple. You just create a person. You want to store on your database, do whatever you want. And at the end, you want to notify that person that the account has been created, for example. So this notification service, it's just an interface with this method. So what we are doing here is mocking this interface. Okay, so you can use this mock, this mock, SPOC mock. So I'm mocking this interface. I have here an instance of that mock, and just I'm creating my user service, the thing I want to test with this mock. Okay, I'm just injecting this collaborator, and when I execute this code, this is what should happen. I expect that one or this method will be called once and only one time in this collaborator. And here I'm saying, let me show you this. The first parameter is a person. The second one is a message. So with this underscore, I'm saying I don't care about the person, but the message needs to be user created. So if I run this test, it passed because this is I'm executing this, and this is the message. But if for example I'm refactoring this thing and I comment this code and I forget about it and run the test again, it's going to fail because there are too few invocations for this thing. I was expecting one, but nothing happens. 0 invocation. Okay, let's fix this. And you can also, here I have 2 parameters and I only care about the second one. But if you have a lot of them and you don't care, you could do something like this. And here you are saying, I don't care about any of those parameters. Yet I only want to check that this method it's called. And if you don't care about the method, you can also put here the underscore. Okay, let's run it again. Green. And if you don't care about the mock, okay, see what I'm doing? You can put here. And if you don't care about the number of executions, you can say something like this, which it's something like an emoji, and it doesn't mean anything. O sea, if you write this, oh, please don't write this code because it doesn't mean anything. Sorry. But you can see that you can do a lot of things. So for example, instead of this, you can also do here, I'm going to execute this method once from 1 to 3 times. Or one common pattern is something like this. Let me copy this. So something like this, and then you put here this. So I don't want to execute anything else. If one mock is executed on that test, it should fail. So this is useful with a 0, but not with something like this. So please don't do that. Okay. So in the second example, in the first one, I don't care about this parameter, but here I can check something on that parameter. So this is the same. And as you can see here that I just create a new instance. This is a private instance for this method. And I just call the notification service with this person. So I cannot access to this person variable outside this code. But what I can do here is using this Groovy closure. And I can check that the name, so this is a person, should be Ivan. So I can run it. And it passed. And if I change, for example, here, or imagine that, imagine that I hardcode here John, and I run the test again, it's going to fail because this wasn't invoked, and SPOC said, okay, this hasn't been executed, but I don't have a match for this, so maybe this is the thing you're looking for. And you can put it here. This is a Groovy closure, so you can put it here, whatever you want. You can say, and IT is the implicit iterator or the implicit value for every iteration. I can say IT last name. So if I now fix this name, Sorry. Oh, let me do this. So it's going to fail again. Now if I fix the test, it's green. So you can do whatever you want. You can check whatever thing you want. Okay, in these examples, I was mocking an interface, but sometimes, let me close this. You want to mock an implementation, and for that to work, you need, come on, you need to add this file that I removed here. So you need to put cglib on your class path, and with that library on your class path, you can now mock implementations. So I have created this email service. It's just a demo, so I'm just printing this message, but I want to mock that implementation. And from the test point of view, it's the same, mock and the name, but with this cglib on your class path, you can just mock it. If you don't put that jar, it will fail. But the SPOCs in the error message will say you should probably want to put that on your class path because you are trying to mock an implementation. And the last thing is that sometimes you want to check more than one thing and in a specific order. So here I'm sending 3 messages, and I want to be sure that the order it's this one. So I can run this test, and it's going to pass. And the thing is that you need to put this then. If I delete this and do something like this, and for example, so no, let me do this. I'm going to check the order of the messages and run it again. So now the test is going to fail. Hello? What happened? Oh, it's here. So it has failed. But if you do something like this, the test pass. Because SPOC doesn't force the order for the whole then block. So remember, if you want to check the order of the execution, you need to write a then block for every one of them. It's a little bit verbose, but this is what you need to do. And another thing that you need to do sometimes, instead of mocking, it's stubbing. So remember this previous example, you have this code and you want to mock this collaborator, but sometimes you want to check that this collaborator returns some value. Sorry. So this is an interface. You can see this, imagine that this is something like a Spring Data or something like that. Find by ID, that will return a person, or find all by last name will return a list of persons. It's just an interface, I don't have the implementation. And with this stub keyword or method, what you do, it's saying for every method or for every time you call this find by ID method, and I don't care about the parameter, please return this person, this object. Because remember, find by ID will get an ID along and return a person. And for this example, I don't care about the ID. So I can call it find by one, and the person will be John Doe, because this is what I'm returning here. If you want to return more than one value, here I'm using this write-if operator, and here I'm using this one. I don't know the name. Let's call it super write-if operator. And you have this list. So for every iteration, you are going to have one element of the list. And remember, I don't care about the ID, so I can call it 3 times with the same ID. And for the first one, the person will be John. For the second one, will be Jane. And for the third, for the fourth, and so on, it will be always the last one. So you can see here, I'm calling this 3 times. And the person 1 is John, and then Jane, and Jane again. Let's run this. Okay, green. And here you can also say, okay, now I do care about the parameters. So if you call this method with 20, I will return Jane. And if it's 11, it will be John. And it doesn't matter the order. So I'm defining here first the 20, and I'm using first 11. 11, it's John. So person 1, 11, John. And 20 will be Jane. Okay? And now, sometimes you can also check what happened when this collaborator throws an exception. So with this here, you put this inside of a closure and throw, for example, a runtime exception. And you can use this throw method that we saw before. This is basically this one. In Groovy, in most of the cases, the parentheses are optional, but you can write this code just like this. And as in the previous example, I'm throwing this exception with this error message, and I can check that this message is what I expect. And you can combine, so you can define here this, put on a list and return, for example, the first one an exception and the second one a person, or whatever you want. And in the last example, what I want to show you is that you can define more than one method, and it doesn't matter. So this interface has two methods. I only have been using the first one in the previous examples, and here I'm using both of them. So I don't care about the ID with person ID. I want Peter Smith. So with a random number, it will be Peter. And here, if I find by last name with Doe, it will return this list, because remember, this is a list of person with these two names, John and Jane. So I can check, for example, the size is 2. Okay. So let's move to the next one. Okay, sometimes you want to check, imagine that you have a test, something like this, and here you want to check that when you add this 21 number, the size of the list has been increased. So you will probably do something like this. Here you can say, okay, number size is numbers.size. I'm going to save it here. And then I expect that numbers.size is equals to this value that I saved previously plus 1. So, okay, it's green, the test passed. And you can do it in this way. It's not wrong, but with a SPOC, you can do it better. So let's remove this. And what you want to, or you really want to do is that now number size is equals to the old value of numbers.size plus 1. So SPOC is doing the same as I did before. So he said he watched and said, okay, numbers.size, it's here inside all in the then block. So SPOC is going to move this here. It's going to save it on a variable and then compare. But you don't need to do yourself. You can just use this all method as a shortcut. Okay. Next one. So imagine, I'm going to comment this code. Imagine that you, for example, create an object or something like that, and you need to assert a lot of things. So person dot whatever equals whatever, and you have a lot of them. You can write this just like this, or you can use this with block. So inside of this block, in this closure, you can access to this all the elements of this person. And as you can see here, IntelliJ knows again about this. This is a person. So you can use it, or you can also use the Java getter. It's the same. So this is just a shortcut for doing a lot of comparisons in the same object. And for example, if this last one fails, you can see here that failed in this last name. So it's basically the same, but with this new shortcut. Okay, and now I'm going to show you some example, because sometimes imagine that you have a project and you want to test, or you have some tests that only run on your CI server, for example, for Linux, for Windows, or for different things. And you don't need to worry about the test why or how execute or how ignore the test if it doesn't fit something. So you have this at requires annotation and these shortcuts. So this test is only going to be executed if the machine is Linux. So it's true and it's going to be executed. I'm running Linux. And this test, it will be executed in Windows. And I have here this false because if it is executed, it will fail. But as I'm not running in Windows, it's going to be skipped. And you can also check, for example, the JVM version. So you can say, okay, this test, as the same with requires, you have this ignore if. So you can say, ignore this test if the JVM version is Java 8 compatible, which means Java 8 and 9 and so on. I'm running Java 8, so this test is going to be ignored. And you can also say, okay, ignore this test if I'm running Java 9. And you can also write your own methods. So here, imagine that you have here some arbitrary code. You can say something like this. I need that this method will be true to run this. So here I have defined this static method here. So let's run the whole suite. And as you can see, the Windows test has been ignored. And the Java 8 Plus has been ignored because it was ignored. It was required and it was ignored. And the trick with this thing is that you need to define this method static inside of in your class if you define here, and you also need to import the static this method. If you don't do this and try to run the code, it will compile, and the error is pretty bad because you are not sure what or why happened. You can fix it just importing static the same method on the class, or just using here E12 requires ignore if. Sorry, not here. Here. It's the same. Okay. So next example. Sorry. With this timeout annotation, you can check that your test it's going to. So for example, imagine that you want to test something and you have this time constraint. So this test should fail or will fail if it takes more than 500 milliseconds. So as I'm sleeping this amount of time, it's going to fail. No, I'm not running this. I need to remove this. Okay. Okay. Method timeout after 0.5 milliseconds or seconds. So if now I sleep less, the test should pass. Okay. And the last thing I want to show you, let me do this. I'm going to run the whole suite, all tests. I'm going to comment this. So it doesn't matter. It's okay. Some tests fail, some tests pass, sometimes were ignored. It doesn't matter. So if I execute for every build that I run, I have here this report in reports. So let's open it, Firefox. And this is the standard report. So you can see. Let me do this again. Okay. Okay. So you can see some tests failed, some tests were ignored. I have the packages. I have some percentage. some classes, and you can see all of this. So if I go here, so I can see the string, the name of the methods. So this is the standard SPOC report, but I can do here, if I add this file, this dependency, SPOC reports, and run the test again, I have this another directory, and let's open. And you can see it's basically the same data. But the nice thing about this report, there are two things. So the first one is that you have here. Remember when I wrote the first test? Let me do this. You can write here these labels inside of every given one then to explain it better. So with the SPOC standard report, you don't have access to this. But with this SPOC report thing, you have. So you can create a report extracting all the information from your text, from your tests. And you can also customize this report. This is the default layout, but you can put your own CSS, your own template, and just create the report as you want. So it's a nice way to just create this report for other teams or for some business people or something like that. Okay, so that was my last example. These are the results. The first one is the SPOC framework web page. The second one is the GitHub repository. And here you have the documentation. It's pretty nice. There are a lot of examples there. And that's all. This is my contact information. I'm going to, well, push the slides. There are only 5, but I'm going to push the code to GitHub. I'm going to tweet about it. And here in this QR code and this URL, you have, if you have 30 seconds, it's an anonymous Google form with only 4 questions to send me some feedback about the talk. So it's anonymous, so you can say whatever you want. If you like it, please say it to me. If you think it's crap, say it to me. It doesn't matter. I don't know who you are. It's anonymous. And now we have time for questions. If you have some questions.
Thank you for presentation. Can you give examples? Who is using Groovy on big companies, for example?
Netflix? Do you know Netflix?
Netflix yes, I know.
Netflix is using Groovy.
Okay.
Who else?
Who else?
Vodafone. Okay. LinkedIn también also is using Groovy. A lot of companies. It's not, I mean, there is not so much marketing around it, but there are a lot of big companies using Groovy.
They're using only Groovy or mixing?
With Java code. The nice thing about Groovy is that you can use any Java library from Groovy. You don't need to do anything else. Just put the jar file on your class path and you're done.
Okay, clear. Thank you.
You're welcome.
Hi, we have existing Java unit tests, so why would I want, in JUnit, why would I want to rewrite them in Groovy? I haven't seen any positive sides. I'm sorry.
So you don't like the throne? You don't like the data tables?
It's just the syntax sugar. What's the benefit besides syntax?
It doesn't sound too much for you. I mean, you can write highly expressive tests with less code in a very nice way. It doesn't matter. I mean, it's not production code, but you need to maintain this test. You need to write. You need to evolve this test. I mean, if you are happy with Java, okay.
Because in Java, to make the test expressive, just write a nice name, have like a nice separate.
With underscores and all of this, or with
like
camel case.
Yeah.
Okay, that's not nice for me. Sorry.
Okay.
I prefer white. Just write plain English.
Can I answer to this question? Is the where block in a classic JUnit test, the where block, what SPOC tests have, look just ridiculously difficult and hard to maintain. I use SPOC, and that particular benefit, that particular feature in SPOC test is just awesome. In JUnit tests, you can very easily test a single method with different data sets, and in a JUnit test you have to like write new lines.
Yeah. Thank you. More questions?
How hard is to add SPOC to existing project? Only those jerseys needed?
Sorry, the question was how to add SPOC to an existing project?
Yes.
Just as I said before, if you are using Gradle, put those dependencies, and if you are using Maven, you basically the same. Put those dependencies, and you are done.
And use Groovy type.
Yeah, I mean the code for the test is Groovy code, but it's only for tests. If you are afraid to use Groovy in your production code, it doesn't matter. You can use it for test. Probably if you feel more comfortable about using Groovy in your code, in your test, in the future you will use Groovy for your production code.
And is it only for unit tests or also for integration
test? Yeah. And if you are using a Spring, there is another dependency, SPOC Spring, that you can throw, and yeah, it will start the context, and you can do integration tests and all you want to do. And also you can create there is another tool called JEB, G-E-B, which it's for functional testing, something like Selenium. It's a layer on top of Selenium with this nice syntax and all the Groovy thing.
Please use my.
Yeah, this was something very new to me. You said that you can spin up Spring framework from SPOC test. Does it happen once for all the tests if I have multiple Groovy files with SPOC test?
Nice question. I don't remember. I need to try it. I think it will create it's for integration test, so I think you will have the context one time for all your tests. But I'm not really sure.
So I can also auto-wire something in the SPOC test?
Yes, you can.
Okay, so thanks.
Thank you.